Not long ago, downspouts and roof drains in Milwaukee had to be connected to the city's sewer system, but no longer. Now it's voluntary, and homeowners are being urged to disconnect. Officials say rainwater entering the sanitary sewer system is a major cause of basement backups and sewer overflows. A pilot project to disconnect downspouts will measure exactly how much can be diverted in one small area.
This is a demonstration project that has been sponsored by MMSD and the City of Milwaukee to find out the effect of removing downspouts from direct connections to the combined sewer area. The intent is to remove as many downspouts as possible, which is almost totally clear water, which in fact keeps down the cost of processing the sewage because it doesn't need to be treated. It recharges the groundwater and in some cases keeps water out of basements from flooding.
Well, Tom, it can make a significant impact when you multiply all the homes in the city of Milwaukee in the area and imagine that in many cases the downspouts are connected directly to the sewers. We're talking during a heavy downpour, the engineers estimate nearly 300 million gallons of clear water, which eventually goes into our sewer system, results in some cases in overflows, and then puts partial raw sewage into our Great Lake, Lake Michigan. We're trying to do as much as possible to avoid that. Certainly the sewage district is looking at making changes and expanding the deep tunnel, but that is extremely costly. This is a much more cheaper matter in trying to divert that flow back into the water cycle, back into the grass, goes down into the groundwater, recharges the system, that cleans it naturally. Milwaukee Metropolitan Sewage District is funding this. It's for about 200 homes in this area between basically 16th to 20th Street from McKinley to Galena. And we just want to see if it works. We want to maybe look at expanding it in other parts of the city.
In these before and after pictures of a home in the demonstration area, MMSD shows how landscaping can provide an area for clear water to be absorbed into the soil. Community Service Corps members will not be landscaping as they do the disconnections. MMSD will, however, help pay for landscaping projects.
This project is a demonstration project where we have demonstrated what wet feet plants can be used and how they can be used to absorb water, to keep water from flowing over driveways, to keep it off the sidewalks, and to recharge the groundwater. In the other projects, we will be physically disconnecting the downspouts for the people, and then we will be giving them certificates so that they can buy up to $500 worth of plant material at Miners Garden Center and only pay $250 for it. The current criteria is it has to be a residential home. One of the things that you don't want is you do not want water that will go over your sidewalk. You don't want water to go over your driveway. You don't want to have to lead a downspout over a sidewalk where you can trip over a sidewalk, or you don't want it in front of a doorway.
You don't have to be in the pilot project area to disconnect.
With the ordinance the way it is right now, any one or two family home can disconnect their downspouts. They have to make sure that they keep the outlet 2 feet away from their basement. They have to keep it 5 feet away from the property line. They cannot let the drainage go over sidewalks or driveways or cause any other problems.
Engineers estimate that during a heavy rainfall, each roof sends 12 gallons of clear water into the sewer every minute. That's millions of gallons, leaving less room in the system for genuine wastewater, more of a chance it will back up into basements. MMSD says 6 homes with downspouts connected to the sanitary sewer system have the possibility of causing backups in up to 200 homes. Clear water also causes other flooding problems. Years ago, the idea was to convey water as fast as possible. While concrete linings did that, urban development sent more and more water in, and they often backed up flooding areas along the waterways. For 30 years, residents near the usually quiet Lincoln Creek corridor faced flooding on a regular basis during heavy storms. Now the area has been forever changed by the Lincoln Creek Environmental Restoration and Flood Management Project. While work remains mainly on culverts and bridges, MMSD says the flood control functions of the project are substantially done, about 2 years ahead of schedule.
We were getting a series of flooding events that seemed to be happening in rapid succession. We had a flood in 97 and 98, again in 99, and we just seemed to be having a much wetter pattern of rainfall. And the citizens of the area were very concerned that they'd have to experience another flood. And so we tried to accelerate the program actually to accommodate their needs.
Percentage-wise, how far along are you, do you think?
I'd say at this point in time, we're about 90% done with the project, and maybe even a little bit closer to about 94% done with the project. There's still some things that we consider, in terms of flood functional, it's 100% flood functional. It's just that there's a lot of cosmetic things that still have to be done. We're doing a lot of vegetative planting still and landscaping in the areas. There's some painting that still has to be done on some of the bridge abutments and the like, and the walls. And then we're putting in the last of the bypass culverts, which actually allows water to pass the bridges that we have here.
Lincoln Creek drains a 21 square mile urban watershed, most of it located in the city of Milwaukee. The majority of the work was done in Alderman Marvin Pratt's district.
You know, I remember having a meeting in July, right after the first flood in 97, where we had over 700 angry residents at All Saints Church and who just wanted something done.
The project that was done greatly reduces those flood risks along the densely populated 9-mile-long Lincoln Creek corridor. It moved the floodplain away from over 2,000 homes and businesses. The creek was deepened in some areas, widened in others.
We actually added and restored some of the natural floodplain that used to be along this creek. We bought properties and we lowered some areas so that this river would have a floodplain again. And that kind of was the other thing we did besides the detention and the conveyance aspect. We actually reconnected the floodplain to certain areas of the river where we could.
Where concrete once lined the creek, a more natural, meandering waterway now exists to keep the creek's flow within its banks during heavy rainstorms. Residents played a key role.
A lot of the people in this area sat in on what we call our stakeholder meetings, and they were allowed to express their views. We had a number of public meetings, and people were able to express the views and what they'd like to see for the creek. They talked about safety features, they talked about open siting, they wanted vegetative areas, they wanted places to recreate, and then of course mainly they wanted to have some safety from flooding.
Very, very pleased. It's MMSD has done really a marvelous job with the Lincoln Creek project. I think it started off about $70 million. I think they may have gone over that, but as you can see here, you know, the natural vegetation and natural landscape, you know, taking out the concrete, and they've just done a wonderful job. So they are to be commended for doing this ahead of schedule, and that's really what's most important to the residents who lived here. You know, in 1997 time, we had had a flood in 97, 98, 99. And a lot of these people were thinking about not just leaving this area, but leaving the city of Milwaukee. We did purchase a number of homes and raised a few homes in the area, but based on what was done here by the sewage district, I think a number of people have chosen to stay in Milwaukee, and so it's just a wonderful public works project.
Primarily for the flooding aspect, we used what we call detention, which holds water back in large areas where we bought properties to hold water on, like a natural floodplain would do. And then we did what we call conveyance, where we could lower the creek somewhat and widen it. So we could pass water down to these bigger areas that we could hold water in. So it was conveyance or holding and then conveyance. There's two detention ponds, what we call detention ponds. One's at Green Tree Road and 51st Street. And that's a dry, what they call a dry pond. So when the river gets to flood stage, it spills over a earthen embankment into this holding area. And it holds it there until the flood peak recedes, and then water feeds back into the river. And it's dry most of the time of the year. The other one that we built is in Haven Woods State Forest, and that one's wet. So it has wet features to it, it has a wetland to it, and then water will go into that on a regular basis to keep it wet, and it also has water quality benefits associated with it.
Between 1960 and 1997, more than 4,000 separate flooding problems were reported along the creek. Could it happen again?
We are close to being out of the woods. It'll handle most of the storms that we see in this area. But again, I will not say that we'll never have a flood, because always can be a bigger one. But this was designed to handle what we call the 100-year flood frequency, or the 1% probability flood.
We continue our discussion on the Milwaukee Metropolitan Sewerage District with its new Executive Director, Kevin Schaefer. And welcome to our program, first of all.
Hi, Tom. Thank you.
Kevin, you're not new to the district, but you are new to this job.
Yeah.
Tell us what you'd like to accomplish and what your goals are.
I've been at the district for about 3.5 years. 1998 I came, and what I've seen in the time that I've been there is that the MMSD, the Milwaukee Metropolitan Sewage District, is doing an excellent job with a lot of the efforts that we've gotten in place. The Lincoln Creek project that you've talked about earlier is one of those. What I really see as a goal and an objective for me is to get that message out to our constituents in the area, both in Milwaukee and the 28 suburban communities that deal with us. We really need to talk to folks and to let them know what we're doing, find out what they want us to do in the future, and to meld this together into a future plan that really benefits water quality and the quality of life for people here in Milwaukee.
What kinds of things do you think you might be doing to get that message out?
Well, we've got a 2020 facilities plan that's just starting up, and to work on that plan, we're trying to start off a partnership that we want to call the Milwaukee Water Quality Partnership. And the reason we need to do a partnership is the sewage district has certain jurisdictions, things that it can work on. What we're finding now with the water quality in our streams and rivers in the lake is that there's other factors that have a very strong impact on the water quality in our area. And some of those things we don't really have a lot of control over. So we need to partner with the other communities, we need to partner with the business community, the environmental groups, and really attack it as a group. I played sports when I was a kid, and we always knew that if you worked as a team, you got something done better than if you tried to do it individually. And I think that same approach needs to be done here. We need to team together, we need to partner, we need to attack this issue.
Let me get your input on the things we looked at, the rainwater reduction, the downspout disconnection,
Sure.
and the Lincoln Creek project. Lincoln Creek, first of all, it's been called a national model for flood control and environmental restoration.
Yeah.
Why is it seen as a national model?
We're very proud of the Lincoln Creek project. This project is a national project. It has national impacts because most places, when they do flood management work, they just go in and they try to take care of the quantity of flow that's coming through. The Lincoln Creek watershed is a very urban watershed. We had over 2,000 homes that were being flooded by the 100-year storm, the 1% probability storm. So what we're trying to do is to build this project so that it's not just a flood management project, but it also enhances the neighborhood, it enhances the environment that the neighborhood is in, and really turns the people back to the creek so that it becomes an asset of the community, and it's not something that they turn their back to.
With that, we mentioned that people had the residents of the area had quite an impact on the design or the final project there, but you'd like to see them continue that and work in the restoration of the area as well.
Yeah. We've done several efforts, both at the beginning, before we even turned the first shovel of dirt, to really get the input from folks. We went out to public meetings. There were some big storms in 97, 98. Went out to folks, and they weren't always happy with us when we were at those meetings, but we listened to what they wanted and we went forward with some of their ideas. And from the very beginning, we had what we called a steering committee that was composed and chaired by our State Representative Shirley Krug. Had people at the table for the steering committee that could bring all the issues together at once, so we didn't have to say, well, what if so-and-so said this? We had them at the table and we addressed the issue up front. And I have to applaud Shirley Krug for really taking this project and making sure that it got done the right way.
Dealing with all the water that's coming through was not the only issue you had to face, and there were some environmental concerns, including habitat restoration, habitat concerns, including animals. And a snake came into play here, didn't it?
The Butler garter snake. The snake itself is not endangered, but the habitat for that snake is. And if this area, it's a very urban area. We did encounter these snakes on Lincoln Creek, and so part of our project was we had to collect these snakes. We had to basically house them, put them in a little snake condo for 2 years during construction. And then we have to release those snakes at the end of the project, and they will go back and they will become part of this natural habitat that was there before and will help to restore the area.
Rainwater reduction, downspout disconnection, can one homeowner really make a difference here?
They can, and that's the whole issue with the 2020 plan and this watershed partnership. We need people to know both what we're doing, what other agencies are doing, what the business community are doing, but they need to have a hand in it too. There's a lot of stuff that they can do with the I&I, the inflow infiltration program. If they have downspouts that go down into the ground at their house and goes into a sanitary sewer, if they've got a grassed area on their property, they can disconnect those and take a substantial amount of clear water off of their property or off of the sewer system and onto their property, and basically use that water to water their yard. What we're looking at right now is something called a rain barrel, which is a 55 to 60 gallon jug that you put at the bottom of your downspout. It collects this flow, and then it's got a spigot on it, and at a later time you can use that water to water your yard. The water's soft, it's more of a ambient temperature, so it's not the cold water that you get out of a faucet, and it's better for your yard to water with. So there's a lot of efforts that the local homeowner can use to stop the quantity of flow that comes off of their property, or at least minimize it. And then just the water quality issues of how do you wash your car, how do you handle used oil if you change the oil in your car. All these issues, you don't want to go and pour it down the drain that's in the street, because that usually goes straight to the river or the creek that's near you. It's a water quality issue.
The infiltration and inflow issue not only affects the homeowner, what about beyond the property line and the infrastructure that you control or that the municipalities control? What's being done there?
Yeah, what we have, what happens is clear water, this water from infiltration and inflow, gets into the sewer system. And it first flows through the municipal sewer system and then hits the regional system, which is the MMSD system.
And rainwater is such a large extent. I saw something that the DNR was saying 99% perhaps.
Yeah. When we have an overflow event, 95 to 99% of that water, by the time it gets to that point of an overflow, is mostly clear water. There is still some untreated sewage in it, and we need to address that issue with this future planning. But the majority of what we have overflow right now really is clear water.
Let me ask the question that so many people are still asking. What about the deep tunnels? Weren't they supposed to handle this entire situation, take care of this overflow problem for us?
Sure. The deep tunnel system came out as a result of a lawsuit in the early 1980s. And so during the early 1980s, mid-1980s, we did a lot of design. We worked with the DNR and we worked with the Environmental Protection Agency to really size this tunnel. And if you understand how the federal government works, they gave us grants to fund the deep tunnel system. So they paid for about 55% of that tunnel system. We were the only community, or one of the few communities, that really took advantage of these grants. Now what you have are loans, which you have to pay back in the future. And what EPA and the DNR required when you do this is you have to do a cost effectiveness analysis. So we got 55% funding from the federal government and from the state government, and we had to go through a cost-benefit analysis. And it turned out that the 400 million gallon vessel that we have storing water was the most cost-effective approach. We could have doubled the size of it at that time, but what you find is you can store as much water as you want from the sewer system, but it's the urban runoff that's really causing the problem with water quality now. And they recognized that back in the 80s and 90s. So it didn't make sense to keep building the tunnel bigger and bigger when you had runoff coming from parks, coming from the street with all the oils and the rubber from the vehicles going directly into the waterway. You'd still not see a water quality improvement. And the tunnel was built for water quality to reduce overflows. It wasn't built to manage floods.
You recently completed a physical inspection.
Yeah.
First time that's been done since the system went into operation. Kind of review what you found and what those findings mean for the future of the deep tunnel system.
I'm an engineer by background, so this was an exciting project, and I really thought this was a great project for the district to undertake. When the tunnel went online in 1994, they determined that we probably needed to inspect it about once every 5 years. So we started that process in 99, 2000. We did spot checks of the tunnel, and it looked really good. What we did this year during the dry season, because we want to do it when the tunnel's not really being used, is we went in and we sent a crew down into the tunnel and we videotaped the entire 19 miles, 19.4 miles of tunnel. And what we found was during construction there's lined sections where there's a concrete lining and there's unlined sections because it's 300 feet down in rock. What we found in the unlined sections, at the time when we built the tunnel, there were cracks in the rock at that time. They were leaking at a certain rate. What we found when we went in this last February was a lot of those cracks have sealed over. They've healed themselves by calcification, like you'd see in a cave with stalactites and stalagmites. So these cracks have healed over, and you don't see the seeping coming into the tunnel the way it was in 1994. So we see a lot less flow, almost half as much, coming into the tunnel as what we thought we would have when we first designed it. So it's much drier than what was anticipated. There are also concerns in the public about the structural stability of the tunnel. This is 300 feet down. It's in solid rock. We had pretty good feeling going into the inspection that it was still working very well and that the structural stability was good. When we got down in there, it was beautiful. We found one boulder the size of a basketball that had fallen from the crown of the tunnel down. The rest of the sediments, and we did find some sediments, the rest of the sediments were more the sands and the fine material. Basically stuff that washes in off the streets and off of development and gets into the system. That generally will flush itself out as we have an event when we have flow into the tunnel.
There is an expansion program going on as well with the tunnel program. Maybe you'd explain that.
We've got a 405 million gallon tunnel right now, the Northwest Side Relief Sewer project, and what that tunnel will do is add 88 million gallons of storage to the system. So we're going to have almost another 25%, 20% more storage in the system because of this one project. It's going to take about 4 years to complete. It's going to be about 150 feet deep. It'll be in rock. It'll have a 1-foot concrete lining around the edge of it. And it's really going to help mitigate any future potential for basement backups and really help us to operate the system better. We're also doing a project that we call real-time controls, which is another way of saying we're putting in new computers to operate everything. And what this new computer system will do, it was originally installed in 1986. This new system will be able to track storms with more recent technology, radar and so forth, and be able to tell us where a storm looks like it's going to go, what we think the rainfall is going to be at that storm. We'll have a better prediction tool to predict how we need to operate the tunnel system. So that, along with the Northwest Side, is really going to improve the efficiencies of the system.
You were criticized for some overflows that occurred earlier this year. The first one was in April, I think.
Right.
Do we say never on some of these things? And
Yeah.
Secondly, how do we compare with other cities in the country?
We've had one overflow this year. It was about 25 million gallons, which we don't want any overflows at all. Our goal is to minimize to zero if we can. But you never can say never, because Mother Nature is always going to throw a storm, either a very large storm that throws a lot of water on the system, or it's going to be a very small, intense storm. The storm that we had this year was really due to some construction work that we have going at the South Shore Treatment Plant. This is a 4-year contract to improve the process at South Shore. And when you have a rain event, you can either store it or you can treat it. We had filled up the deep tunnel system at that point, and we were treating as fast as we could. But at South Shore, which usually treats about 280 million gallons per day, we were down to 175. So because we couldn't treat at full capacity because of these improvements we're making, we had this overflow. How do we compare with other agencies or cities in the United States? We're the leader, and we tell people this because when you look at overflows, we average 50 to 60 a year before the deep tunnel system came online. That was like 8 billion gallons a year, and that was the average. We average 2.5 overflows now per year. And if you look at St. Louis, Pittsburgh, Minneapolis, St. Paul, St. Louis has 90 to 100, Pittsburgh has 90 to 100. They still have a lot of overflows in these other communities. We basically, in the 1980s, took advantage of these Clean Water Fund grants. We built our system then to address these overflows. Of course, we did it because of a lawsuit, but we still did it early and got 55% funding on this system. And we've significantly reduced the overflows. And that's why when we look to the future, we say, okay, the overflows, you're never going to get rid of them. I mean, there's always that potential that you're going to have one. But, you know, we do have them, but there's other things that are causing the water quality issues. Let's look at those other issues and really try to improve the water quality for the future.
Only about a minute left, but are there any kind of technological things coming down the line, innovations that are going to make your job a lot easier and eliminate some of these problems?
It gets back to the inflow and infiltration. There's been a lot of new work with relining existing pipes. And before you could do it for a 24-inch pipe or a 36-inch pipe. But now they're able to do it to an 8-inch pipe. And so they're getting smaller with their technology for lining sewers. And the pipe that goes from people's house to the streets, the home lateral, is usually a 6 to 8-inch pipe. And that is where the worst inflow is coming into our system, is off this private property. We have about $50 million budgeted over the next 6 years to look at private property I&I. And one of the items that we'll be doing is lining these smaller pipes with this plastic material that'll add about 50 years of life to the pipe, but it'll also significantly reduce the inflow.
And how are Milorganite sales going?
Milorganite sales are good this year. We had a bad year last year. Some people think it's because of the 9/11 event. But this year, as of about an hour ago, I just found out we're way ahead, so we're doing good this year.
Okay.